This is Chapter 5, Homework Number 2. We'll start with Monday, 5-86. Identify the following sequences as arithmetic, geometric, or neither. And then for arithmetic and geometric, identify the common difference, common ratio. Let's start with A. Well, 12 plus 132 is 144. And if I add 132 again, it's definitely not 1,728. So I know that this is not going to be arithmetic. We're not adding some constant number. But let's check if it's geometric. So the way that you do that, the trick is you take the second number, 144, and you divide it by the first number, which is 12. 144 divided by 12 is 12. Okay, so let's test that out as a common ratio. 12 times 12, yeah, that's 144. And then, checking this in your calculator, what's 144 times 12? Turns out, it's 1728. So this works, confirmed, this is geometric, and the common ratio is 12. All right, let's try C. Okay, 0 to 4, that's plus 4. 4, if we add 4 again, that'll take us to 8, but this list goes to 16. So this is not going to be an adding list. We can't add a constant number to go to the next term. So it's not arithmetic. Whoops. It's not arithmetic. Now let's try geometric. The trick here is, it looks like 4 times 4 is 16. 16 times 4 is 64, but we have 36. So it looks like it's not geometric. But you can also realize that 0 times 4 is just 0. So no matter what you multiply 0 by, it'll always come out as 0. So this is not a list that multiplies, it's neither. Make sure you do B and D. 5-87. Write the first 5 terms of each recursively defined sequence. T of 1 is the first term. So we have -3 as our first term, comma. And then the recursive equation says to go to the next term, that's equal to -2 times the now term. And let me actually move my list down to the bottom. So this is going to be -3 as our first term. And to go to the next term, we take -2 times what we have now. It's times -2. 6. Then, now we have 6. To go to the next term, we take -2 times what we have now, which is -12. And you keep going in this pattern. Times -2, times -2. So this is -12, then it becomes 24, then it comes -48. This is called an alternating sequence. It alternates between positive and negative. And there's the first 5 terms. I hope you get started on C. The first term is 2. So the first term is 2. And then, to get to the next term, that's going to be equal to what you have now, subtract 1. So to go to the next term, you take what you have now and you subtract 1. So now we have 2. To go to the next one, take away 1. Next term is 1. So keep going. Fill in the 3rd, 4th, 5th, and 6th terms. 5-109. Consider the following sequences as you complete A through C. So this one's kind of long, and this should say A through B. It's a typo. Okay, so let's assume that the sequences are arithmetic, with T of 1 as the first term. So that's the first term, first term, first term. Determine the next 4 terms for each sequence. Okay, so if this first sequence is arithmetic, 2 goes to 6, we're adding 4. So that means you need to add 4 to get the next 4 terms. 2, 6, after 6 comes 10, 14, 18, and 22. If it were arithmetic, this first sequence, that's how it would look. Then write an explicit equation. So the explicit equation, t of n equals, we need to come back and find the 0 term. So what number could we add 4 to go to 2? And the answer is negative 2. Negative 2 plus 4 is positive 2. So our equation is 4n, that's the common difference, times n, minus 2. Common difference, 0 term. So let's start the next one, and then you can finish the next one. 24, 12. Well, 24 subtract 12 is 12. 12 subtract 12 again is 0. So if this were arithmetic, we'd have to take away 12 each time to go to the next term. So minus 12 again is negative 12, minus 12 again, negative 24. So our sequence, t of n, equals negative 12n. But what's the 0 term? Plus what? Figure that out, and then finish the next and last one for A. Now for B. Would your terms be different if the sequences were geometric? Determine the next 4 terms for each sequence if they are geometric. So now we're going to throw away our work in part A. Pretend we didn't do that. And let's pretend these guys are geometric. So for the first one, 2 times, since it's geometric, now we're thinking about multiplying, and 2 times 3 is 6. So if this were geometric, I need to times by 3 every time. 6 times 3 is 18. 18 times 3 is 54. And we're supposed to determine the next 4 terms. So let's start using a calculator here to make sure we're not making mistakes. Times by 3, times by 3. So the next term would be 486, and so on. Now let's write our equation. Alright, this one's different. This one is 0 term times the multiplier raised to the power n. So what is this 0 term? This mysterious missing 0 term? Well, to go forward in our list, we times by 3. So to go backwards, we do the opposite. We divide by 3. 2 divided by 3 is just 2 divided by 3, 2/3. Leave it as a fraction. So the 0th term is 2/3. If you want to confirm this is right, plug in a number like 2. 2/3 times 3 raised to the power 2. This is 2/3 times 9. Then 2 times 9, that makes 18. 18 divided by 3, that makes 6. And the second number in our list is 6. So that's a way to check your work. Okay, this one is actually pretty long, so let's start the next. 24, 12. If this were geometric, what would you have to times by? Times by a half, right? And if you can't figure that out, the trick is you can take the second number, which is 12, and divide it by the first number, which is 24. And 12 divided by 24 is 0.5. In other words, it's a half. So you always have to times by a half to get to the next term. So the next term would be 6. Half of 6 is 3. Then you have 1.5. Then you have 0.75, and so on. Half, 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 half. So the equation would be t of n equals the 0 term times a half raised to the power n. So what is this 0 term? What number multiplied by a half would give me 24? That number goes here. 5-111. What is the equation of a line that has this y-intercept and passes through that point? Okay, so we can find our slope. There's a couple different ways to do this, but let me just do it the usual way. Let's find the slope. So we do subtracting the y-coordinates, x, y, x, y. So subtracting the y-coordinates, that's -9, subtract -3. Then we subtract our x-coordinates, -9, subtract 0. When you subtract a negative number, it changes to addition, so this is -9 plus 3 over -9 minus 0 is still -9. -9 plus 3 is -6, divided by -9, and two negatives make a positive. Be careful here because 3, if you divide the top and bottom by 3, you can simplify. 6 divided by 3 is 2, 9 divided by 3 is in fact 3. So the slope is 2/3. Two-thirds x plus, what's the starting value? Hint, hint, it's right here. So I'll let you finish that one. 5-112. Calculate each of the following values given that function. So let's plug in -3. This is going to be equal to 1 over -3 plus 2. That's going to be equal to 1 over -3 plus 2, that's -1. And 1 divided by 1 is still 1. Positive divided by negative stays negative. Part B. Replace x with -1.5. So we take -1.5 and then we add 2 to it. Use your calculator if you have to, that's going to be 0.5. Do you know that 0.5 is the same as a half? So we're basically saying here 1 divided by a half. And when you divide by a fraction, you keep, change, flip. Keep the 1, change the division to times, and then flip the fraction upside down. 1 times 2 is 2. You can also use your calculator. Use your calculator, 1 divided by 0.5, and that'll take you to 2. All right, try C and D. 121. Think about the difference between a function and a sequence. A certain sequence has this explicit equation. Is it possible for this sequence to have a term with a value of 200? Well, let's calculate the first term. Plug in 1, so that's 5 times 2 to the power 1. That's just 5 times 2, which is 10. Now let's get the second term. 5 times 2 to the power 2. This is 5 times 4, which is 20. And then you can get the third term. 5 times 2 to the power 3. 2 to the power 3 is 8. That's 2 times 2 times 2. That's going to be 8, so it's 5 times that 8, which is 40. Do you see the pattern yet? Remember, this number is called the multiplier. So to go to the next term, we multiply by 2. So 80 times 2 is 160. Go into a new line. 320, 640, but wait. Was there a term that had a value of 200? No. The sequence skips over 200. And it says justify why not. And here's your justification. You drew out all the terms and the sequence skips over 200. So make sure you show your work on that. It's important. How about B? Think about the function with this equation. Is it possible to have an output of 200? If so, what input gives that output? So f of x equals 5 times 2 to the power x, and f of x equals 200. That's what we're looking for. Is this possible? Can this equation, if you plug in something for x, equal to 200? All right, so what we can do here is, think about it like this. 5 times what number is equal to 200? That'd be 50? No. 5 times 40? Yeah, because 5 times 40 is 200. So 2 to the power x would have to be equal to 40. Now what value of x gives this? Well, 2 to the power 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, and 2 to the power 6 is 64. So in between 2 to the power 5 and 2 to the power 6, that 40 is going to come in here in the middle. So what would the exponent have to be? X would have to be between 5 and 6. Now we haven't learned the exact math. You learned this in integrated 3. How to do this. So you don't know the math, but you can figure this out. Some number between 5 and 6 would give you an output of 200. So 5 times 2 to the power 5 would be 5 times 32, and so on and so forth. So I guess the key takeaway here is sequences, if it doesn't hit the exact number, the answer is no. But a function can always have an output. X is allowed to be a decimal, 5.4 or whatever. Okay, let's go to Wednesday homework. Figure 2 is a tile pattern shown at right. If the pattern grows linearly, that means y equals mx plus b. That's what linear means. And if figure 5 has 15 tiles, write an equation. Well, I think a table would help. A table comparing figure number and number of tiles. Figure 2 has 6 tiles. So in my table, figure 2 will go to 6. We also know that figure 5 has 15 tiles. So figure 5 in my table goes to 15. What number could I add and add and add to get to 15? If you're not sure, find the slope. 5 minus 2 is 3. 15 minus 6 is 9. 9 divided by 3 is 3. So let's test out the number 3. 6 plus 3 is 9. 9 plus 3 is 12, and 12 plus 3 is 15. So we found our missing value. Now we can go backwards to find the first term, which is 3, and the 0th term, or the number of tiles in figure 0, which is 0. So you have the growth, and you have the 0 term, or starting value. Plug it into y equals mx plus b. So what's our growth? What's our starting value? 126. Arithmetic, geometric, or neither? Let's look at A. So later on in the sequence, away from the negatives, I can see 159. That's clearly adding 4. 1 plus 4 is 5. 5 plus 4 is 9. So this might be arithmetic. But let's make sure the pattern holds for the negatives. 7, negative 7 plus 4 is negative 3, so that works. And negative 3 plus 4 crosses over 0 to 1. Negative 3 plus 3 is 0, so negative 3 plus 4 is 1. Yeah, that works. The pattern holds. That's arithmetic. How about this one? 64. Let's see, 64, I know this. 64 divided by 4 is 16. So negative 64 divided by 4 is negative 16. And then negative 16 divided by 4 again is 4, so that works. And then 4 divided by 4 is 1. Okay, so this is going to be geometric, but let's get that common multiplier. Dividing by 4 is the same as multiplying by 1 over 4. keep, change, flip. Keep the number, change division to times, and flip the 4 upside down. Times by a fourth, times by a fourth, and so on. So this shows you that it's geometric because you multiply to go to the next number. Okay, try C and D. 5, 1, 27. Let's do B. B doesn't look arithmetic because there's decimals and it doesn't look like a constant is added every time. So let's try division. Remember, the trick for finding a multiplier is to take the second number, 7.2, and divide by the first number, which in this case is 6. That's going to be 1.2. So now let's test this out. 6 times 1.2 is 7.2. 7.2 times 1.2 is 8.64, so it matches. And if I times by 1.2 again, I get 10.368. So the pattern of growth there. Multiplies by 1.2 to get to the next term. It says to write an equation only for A. So do A and then write the equation. 130. Let's make an explicit equation for each recursively defined sequence. Hint, it helps to write out the first few terms. Let's look at B. B says the first term is 3. Then, to get to the next term, you take what you have now and you add 6. So we have 3 now. If we add 6 to that, that's the next term. Okay, now we have 9. If we add 6 to what we have now, it'll take me to the next term. And 9 plus 6 is 15. So this pattern grows by adding 6. There's the first few terms. So right away, this is T. T of n equals 6n. This is arithmetic. So I'll use the arithmetic equation. Now I need to find what is this 0 term. What number would go here so that when I add 6 to it, I get 3? If you can't figure it out, go backwards in the list, not by adding 6, but by subtracting 6. That's the opposite. So this is negative 3, and turns out that's the equation. Do A, and then let's look at 6/8. Complete the area model below. Okay, so let's look at A. 6 times 13x, we multiply to go to fill in the numbers in the middle. That's going to be 78x. And then 6 times negative 21, that's going to be negative 126. Write it as area as a product equal to sum. So 6 times 13x minus 21 equals 78x minus 126. This is area as product. This is area as sum. And that's a 78x. Okay, this one's kind of cool. You have to work backwards to fill in the blank. So this is 4 right here. And I'm going to say 4 times 1 gives me 4. So that means this one would have to be 4x squared. 4x squared times 4 is 16x squared. And so that would mean that this middle term has to be negative 6x, right? Negative 6 times 4 is negative 24, and there we go. So area as product is 4 times 4x squared minus 6x, and then this is a positive 1, and that's equal to area as sum. 16x squared minus 24x plus 4. Okay, do B and D, and then we're on our last one. Here's our sequence: 7, 11, 15, 19. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19, so that means arithmetic. And the common difference, D, is 4. The 0th term, go backward to find the 0th term. Go backward by subtracting by 4. And so the number that comes before 7 would be 3. So here's our equation, T of n equals common difference, 4n, plus the 0 term. All right, is 109 a term of the sequence? Let's find out. Can 4n plus 3 have an output of 109? What value of n would give that?